Alright, here we go. Check 1, 2. Mic check 1, 2. So we'll assume that if you're here, you've already got the DMX plugin installed already. The first thing that you've hopefully already done is make a copy of the light that most resembles the one you're recreating. So today we're tackling moving heads, and we'll make a copy of the default moving head and move it to our project folder. While we can modify the core files within the DMX fixture content directory, anytime you update your Unreal Engine, any changes you made will be lost. So it's best to make copies. We'll start with the clay packy Sharpie since it's easiest. And if you have a GDTF file for it, you can get it working with minimal effort. We'll create a DMX library with a controller set up to talk to our lighting program. In my case, I have to switch my start universe to 0. In my case, I have to switch my start universe to 0, then make a new fixture and name it Sharpie. Now we drag in our Sharpie GDTF to import it, and then select in our fixture settings under DMX import. We select our correct mode and add our newly created fixture type to our DMX library. Drag our new fixture into the world and assign it to its correct patch. Patch the same Sharpie into our lighting design software, and voila, we've got our expected controls all reacting correctly. Our strobe, color, and gobo all match up to what's shown in our lighting software. So at this point, we're going to try another light. Let's say we have a real-life Chauvet trio, and we want to program for it and Unreal simultaneously. The first thing we'll do is make a new fixture type in our DMX library. We don't have a GDTF for this light, so we'll bring up a DMX chart online and fill our attributes accordingly. I moved my browser to a second window, but I'm just copying the info from the manufacturer's website. Patch our new light into our Unreal universe, then drag our fixture into our scene and assign it to its fixture patch. We similarly patch a copy of our lights into Onyx, and we will see that our light is now responding to our DMX signal. The strobe isn't correct, but we can find a steady setting for testing. Zoom works, but color doesn't respond. We'll open up our new trio fixture and do the easy part. Delete the color wheel component and add a color component. That's it. Next, to fix the strobe, click the strobe component, and in the details panel, under DMX strobe, there will be a table listed. Press the magnifying glass to bring up the folder that contains it. You won't have all the random clutter. You can then duplicate the original strobe table and move it to your project. Rename it if you want, then open it up. At this point, you will start to fill out your table according to your DMX documentation. I hate doing this, so I'm using a table I had started before, but you get the idea. You will want to adjust the DMX range and strobe type. Not every option in your light might be available in Unreal, so you can either use the closest thing or just skip them. I don't use strobe much yet, so this doesn't impact me too much, but it's good to be able to get open, shut, and basic strobe working. I was clicking through strobe components to look at what pulsation BPM logic was like. It looked like it expects the BPM in regular numeric notation, since it's taking the interpolated value and divided by 60. But other effects like the standard strobe might work better with a min-max of 1 to 5 or something. I don't really know. Next, I spend way too much time filling out the end of this table. I'm probably not even using these effects right, and don't want to be relying on anything other than the standard strobe for now, but it's cool to have the option. Now go into your fixture and bring up the strobe component again. I keep my strobe tables in the dev folder because I'm a goon, but you can drag in your newly created strobe table to wherever you want to put it. Next, I changed the min-max zoom numbers, but to get things completely accurate, you'd have to also adjust your max distance correctly. So take these settings with a grain of sand. Now, while having our new fixture highlighted in our browser, we right-click our old fixture and use the Replace Actor command. From there, we assign our fixture patch and press play. Color is working. strobe is working well enough for its first few settings. Now I didn't do the geometry for the Chauvet trio because the only 3D model I could find was on SketchUp, and it didn't export as 3 separate parts easily, so I skipped it for now. But our next light, the Robe Robin point light, has a GDTF with 3 3D models available, so we're going to use it to show how to import custom geometry. You can open a GDTF with your favorite zip file opening program, and you can extract the model folders contained therein. Unreal doesn't directly take 3ds files, but the free converter you can find online will make them into easily imported FBX files. Make a folder for our new point light and import those with your preferred settings. You'll probably get some errors. If that's your sort of thing, feel free to look into that and fix it. Now we'll copy our Sharpie again and rename it Point. Move it into the Point folder and open your new fixture. In the Components panel, click Static Mesh Head. In the Details panel, replace the default with your freshly imported head mesh. You'll see our imported mesh is of a different scale and must be adjusted. I ended up settling at 0.05 as the probable scale. If I were less lazy, I could go back and re-import all the models with this scale, but you can also just resize everything uniformly. It also seems that the model included was oriented facing down rather than up. We move our new model to match our previous positions and orientation using the Transform tool. I reused the standard lens with a little resizing and positioning. Since no texture was imported, I just used this texture included with the default fixture. It works well enough. We can now drag our fixture into the scene where we'll notice our beam is a little cattywampus. To make sure I'm moving the right things to the right places, I'll usually reference my default fixtures to see where things should be. I notice that the static mesh beam is at the same height as the lens, so I make a similar change in the point fixture. The spotlight component also needs to be adjusted to account for the difference in fixture size. I like to use the viewport to see in real time what effects changes I'm making in Blueprint are having. Once you've got things adjusted, you can assign it to our Sharpie patch from earlier, since its logic is still Sharpie at this point. We can press play and adjust things in Onyx to see the two lights behaving identically as expected. Moving on, we'll try to drag in a GDTF for a robe point light. Well, GDTF vary pretty wildly in quality. Some only have geometries, others have all the channels and wheels. We'll just have to do things manually. Back in our DMX library, we'll add a new fixture type and enter our information from the fixture documentation. You'll notice 2 gobos, and we're just going to ignore the second one for now. I could have chosen a better example light, but I didn't. Finish filling out your attributes. Add a point to your Unreal DMX library, then assign it to our fixture we placed in our scene earlier. We can see that we are able to control functions like dimmer, pan, tilt, and zoom correctly. Our strobe functions aren't working. We'll have to build another strobe table like we did with our trio, but for now, we will choose a setting equivalent to open. We can see that our light is responding to color changes, but not correctly, and similarly is able to respond to gobos with incorrect patterns. So let's open our point fixture and scroll down in our components to our color wheel component. In our details panel, we can see both a logic table and a color disk texture in our details panel. Clicking on our gobo wheel component shows a similar logic table, and this time we have 2 gobo wheels, one frosted and one not. Now to make our custom color wheel, we have a few options. If we can find an image of the color wheel, we can do like I am here and use a paint dropper and bucket tool to copy each of the colors to its individual file. To get a sample file, you can navigate to the color wheel folder in the DMX fixture content and export any color. I use that as a template and just paste other colors into there and save them as a new folder for the current light I'm working on. You can also find in some GDTFs the red, green, blue values listed as the color wheel, but I don't know how to do that. So back in Unreal, I create a color wheel folder and drag in your new colors. Then open your fixture blueprint. Click the color wheel component and then the magnifying glass under the current effect table. Over in your current content browser, you can now right click your color wheel table and duplicate it. Drag the copy into your project folder and rename it appropriately. Now to edit the effects table. I personally go through and change all my min, max ranges and then drag in my colors afterwards. Finally, making certain that the effect is correct. Swap and rotate do what you'd affect. Mix with previous is probably what you should use for proportional color wheel movement, whereas swap is used for step logic. In this, I just make everything swap because I wasn't thinking about it, but you can experiment and find what works best for you. Once you've got all that done, you can open your fixture again and drag your new effect table into your color wheel component. You will need your color disk though. For that, head back into your DMX fixture content folder again. In the tools folder, right click Bake Disk Texture and click Run Editor Utility Widget. Navigate back to your color wheel effect table and click it in the content browser. Next click Pick in your Bake Disk Texture tool. This will select the table you have selected in your browser in the widget. From there, you can specify a location for the baked disk to be generated, and then click Generate Color Disk. Find the generated image file and drag it into your color disk slot in your fixture blueprint. Press play and you can see your color wheel now working as expected. On to gobos. Open your GDTF with your favorite unzipping application, and if you're lucky, the gobo image will be contained therein. Extract those somewhere, then import them into your project. Then, like our color wheel, we'll click our gobo wheel component inside our fixture blueprint, and from there bring up the effect table location using the magnifying glass. Normally, you duplicate your table and begin modifying it based on your DMX documentation, but I had a brain slip and started modifying the base table. I realized at some point eventually, but because I did this, I'm going to have to go back and fix my Sharpie gobo table at some point. Once I finish my gobo effect table, mins and maxes, as well as assigning their effect, I drag in the correct gobo images. You see me using Onyx to make sure I'm on the correct gobo since I used the wrong set my first try. From there, things are the same as the color disk. We run our Bake Disk Texture tool and select our freshly created gobo effect table. Choose where you want it to end up and click Bake Disk. Find your baked disk and drag them into your frosted and unfrosted gobo wheel slots. That's it. Bring up your lighting software and test to make sure everything is working.